Hello there, everybody. This video is about the law of cosines, and the law of cosines is another way to find missing sides in non-right triangles. Most of the tools we've used so far we've used to find missing parts of right triangles. But law of cosines and law of sines in the previous video that you may or may not have watched, but the previous one that I made anyway. Can both be used for non-right triangles, triangles that don't necessarily have a 90-degree angle. Now, they do both work for right triangles, but with right triangles, usually there are easier ways like SOHCAHTOA and inverse, sine, cosine, and tangent to find missing parts. But law of sines and law of cosines both work for non-right triangles. So this is the law of cosines. Notice in the law of cosines we've got all three sides of the triangle are in the law of cosines. In fact, two of them are here again. And only one of the angles is there. Law of sines had two sides and two angles. And that's really how you know which one of these to use. If the combination of things that you know and are looking for is two sides and two angles, then you use law of sines. If it's three sides and one angle, then it's law of cosines. So the big thing here about law of cosines, or big thing about figuring out where stuff goes, is really has to do with this side and this angle. Okay, the side that is over here on the left and this angle have to be opposite one another in the triangle. So whatever side it is goes there, the angle that's opposite it goes over here, and A and B are interchangeable. Those are the other two sides. So let's take a look at an example here. So here's a triangle. 1, 2, 3 sides and one angle. So the combination of stuff that we have and are looking for, 3 sides and one angle, that means we use law of cosines. If it was 2 and 2, like if we were looking for this angle, now it's 2 sides and 2 angles, that would be law of sines. That's not what we were looking for. We were looking for this side, 3 sides, 1 angle, that's law of cosines. Okay, so the angle and the side that are opposite one another are those two. So the x is going to go here for c. So we're going to have x squared. Now 8 and 9 are a and b, and they're interchangeable. You can do 8 squared plus 9 squared, or 9 squared plus 8 squared, either way, just like Pythagorean theorem. And in fact, I mean, there's the Pythagorean theorem right there. C squared equals a squared plus b squared. Let's go back to our example here and finish plugging stuff in. So a squared plus b squared minus 2 times a times b, so that's 8 and 9, times the cosine of 40 degrees. Now, x is already over here. It's not really solved for x. We still got the squared here, but all we have on the right side are numbers. So all we've got to do is, for this, is evaluate all this stuff. So 8 squared is 64. 9 squared is 81. 2 times 8, boy, I might need a calculator for this one. Let's see, we wanted to do 2 times 8 times 9. 144. So minus 144 cosine of 40 degrees. Now, this is 144 times the cosine of 40. Now, and when you do order of operations, when you're choosing between addition, subtraction, and multiplication, you always do multiplication first. So we've got to multiply 144 by cosine of 40 before we do this addition and subtraction. This is a mistake I see a lot of students making. Do this multiplication first. So let's see, 144 times the cosine of 40. I want to make sure I am in, not in the right mode. Now I'm in degree mode. 144 times the cosine of 40. 110.31 and change. 64 plus 81 minus 110.310, and there. Okay. Now I want to add 64 and 81 and this number here. Now most scientific calculators have a button that's that looks like ANS, and that stands for answer, and that takes the last number that was displayed in the calculator, and it takes all of those digits. So we know that what the calculator spits out here for the next time I hit enter is going to be really accurate. Because that ANS button uses all those digits, and you can still see them. See, they're all right there. Oh, and I totally did not want to add that, did I? Darn it. So here's what you got to do when you make a mistake like that. I didn't want to add here. I wanted to subtract. So I screwed up. So I've got to do 64 plus 81 minus, let's see, 110.3103998. So I just type in all the digits I can. It's a pain. But if you have that ANS button on your calculator, which again most scientific calculators have it, you can use that. It's a lot easier. Okay, 34.689. So we've got x squared equals 34.689 and a bunch more digits. Now we've got to undo this squared. That means we're going to square root both sides. We get x is about. Now I still have that number in my calculator, and I want to square root that number, so I'm going to use that ANS button again. I don't want to have to type in all those numbers. I also don't want to round it off because my answer is not going to be accurate. So I'm going to find that ANS button on your calculator. It is handy. That's going to square root this number with all those digits on it. And looks like 5.8. If I round to the nearest hundredth, it would be 5.89 because this number is 5 or bigger. So I'll put 5.89 as my answer. 5.89. And there we go. That is it. Let's take a look at another example. Okay, again, 3 sides, 1 angle means law of cosines. Now, the angle that we're looking for and the side that's opposite it are those two. So those are the ones that are going to go into the law of cosines here and here. Now this one's a little different because this one I'm looking for the angle, and this first example I did I was looking for a side. When you're looking for a side, the process for using law of cosines is always exactly the same. The numbers are a little bit different, but follow this process, you'll be fine. For an angle, it's a little different. The setup is the same. X is the side. So, 8 is the side. Excuse me. So 8 squared equals 12 and 7 are A and B, so 12 squared plus 7 squared. And A and B are interchangeable. I could have put 7 squared plus 12 squared. That would have been fine too. And they're interchangeable here as well. I could put 12 times 7 or 7 times 12, either way. And then cosine of x. Remembering that this side and this angle have to be opposite one another. And here they are. So I know I've set it up right. Okay, so let's do this here. 8 squared is 64. 12 squared is 144. 7 squared is 49. 2 times 12 times 7 is 168 times the cosine of x. Now, I've got to solve for this cosine x thing. So I'm going to subtract the 144 from both sides. I'm also going to subtract the 49 from both sides. I'm going to do that all in the same step so I save a little bit of space here. Let's see, 64 minus 144 minus 49 gives me negative 129 equals, I still got this minus 168 cosine x. Now this is multiplication here between the negative 168 and the cosine. You undo multiplication by dividing. So I'm going to divide both sides by 168. Negative 168, excuse me. And I'm going to be left with cosine x over here. Negative 129 divided by negative 168. So big long decimal, 0.767 and some more digits. Okay, now the question is, how do you undo cosine? Well, you undo cosine just like we did when we were doing SOHCAHTOA and right triangles. You do the inverse cosine. So x is going to be the inverse cosine of 0.767 and all those digits that we had before. Now, if you kept it in your calculator, like I've been trying to encourage you to, and like I have here, it won't be too bad. So second and then cosine, that gives us inverse cosine. And rather than pushing all the digits, 0.767857142, I mean, it's a lot of buttons to push. I don't want to have to do that. Let me delete all that stuff. It's just not necessary. If you use that A and S button. Remember, that A and S button takes the last thing that was displayed and puts all the digits in there. You got to push 2 buttons to get that to show up on your calculator. This, you've got to, that's like 10 buttons or 11. Okay, use that A and S button, and it'll help your answer be a little more precise, a little more accurate. And we hit enter, and we get the number of degrees, 39.8 degrees. So that is about 39.8 degrees. That is x. And there we go. This is how to find a missing angle using law of cosines. This is how to find a missing side using law of cosines. Hopefully you took some notes. If you didn't, watch the video again, take some notes, or at least be able to pause it when you can see all the work so you can follow it. Hope this makes sense. Good luck on the practice. Get some help if you need it. Bye.